to make discussion. There's a lot of people who are in and out of knowledge in that RAG, especially specifically. Cool. I'm Tom.
Yeah, awesome.
Testing.
Yes.
Computer.
Yeah, I'm unmuting myself. It's
Startup.
technical issues and we cannot hear, and also we're not sharing the presentation.
Testing.
We're okay?
Yes, we have audio now. Can you share your desktop, the slides, please? Thank you.
Not quite sure what's happening. All right. How's that? Great. Okay, let's get back to it. So I'm making schema-controlled automated knowledge graphs. This is what a schema looks like in our instance. I know the word schema is difficult. I know it's used for a lot of things, but this is broadly what it looks like. Now, the point of this is so people who are non-technical or interact in natural language, in this case, English, can constrain what's made. So you define characters or the entities, you define the relations, and then finally you specifically talk about the patterns. So the patterns being the triples, being the constraint. All of this is to say, you might have seen LLMs make knowledge graphs before. And LLMs are fantastic in terms of their generative and creative, and what they produce is entirely often new and different, and then potentially hallucinatory and wrong, right? So there's some great benefits to that. There's also some problems. So what we want to do is make sure we add some documents. So this is a case of just adding the Seinfeld schema up. And then we run create graph. And then we also have a query graph, but you can see that this is our SDK. So in as few lines of code as possible, we wanted to set the documents, set the namespace, bring in the schema I showed you here, but you can edit and just change and redo. And now you can create a graph from that schema. And again, we have create graph from questions, we have create graph from view. I'm happy to talk about them another time, but right now I'm trying to run the create graph from schema. And then if I get out of this, I'm using Neo4j Aura for this example, or I'm using Neo4j more broadly. You can use any graph provider. I really like using Neo4j. I like their auras, very easy for people to use. And now what I want to see is, let me run it and make sure it's running. I'm going to create a graph, right? And so this, by the way, this is a completely free Aura instance. I just have it running here to show that we're making it. So now I can keep kind of iteratively creating the graph. So I'm just running a create statement as I go, a match statement, as I kind of iteratively build out the triples and the patterns. And what you'll notice on the right is that the nodes and the relationships are limited to the ones that were in the schema. It's part of the problem when you create graphs, at least what we've found, maybe someone else in this room solved it, but part of the problem is that you, if you let an LLM make you a graph, it will make all sorts of things. But if I look at this graph specifically, you can see that it's extracted things like Jerry and George, and intentionally threw this in uppercase, lowercase because of Parker's great talk yesterday around entity resolution, and I think that's important. But if I wanted to just lowercase this document, I could. But it's the idea is that you very quickly made this graph, but all of the edges and all of the nodes are timed. So now when you want to query it, you can specifically get back the query you want. And further to this, I'm going to remove this contains limiter. I know this is a small screen, sorry for those. I'll try and zoom in. I'm going to remove the contains limiter. And now we actually have significantly more relations because let's just take this chunk, for example. We've actually, through the RAG process, chunked every document. So our process is chunk or split a document and then do some level of extraction on that document. I know this is a very connected graph. This is part of my point about why graphs are big, right? Because it's difficult to fully see. But in terms of a demonstration, I can subgraph it and limit it. But these chunks or these nodes, this is the information, this is the text that we've then extracted from and got these entities. What that means is that when you query, there's massive benefit to querying a knowledge graph in the RAG process, but you get back the context that made it. This is all to say that we've built something and that it works. We can run it, we can delete it, and we can go through that process. I just wanted to show you that we are building this stuff and we are working with it. This is the type of stuff we do. But now jump back in to what I was talking about. Which is again, why you should listen to me. I've built a lot of graphs in a lot of different technologies. My master's and PhD was largely in Protege and RDF&L, and I'm sure a lot of people in this room have spent a lot of time in that. But we're working in RAG and RAG specifically and how we can improve the RAG process. And so those graphs that we build is like, how quickly can we get someone to seeing what a graph is? I don't know if people in this room have had this problem, but it's like part of the difficulty is people like, graphs look good, I can't necessarily use them. So this is why I like using graphs. Who may agree or disagree, but the relations are the valuable part, right? And I can see it. So there's very few databases where you can see your schema and you can, control what's happening. Again, with the schema example, I can just write something different. If I want different characters, if I want to say sandwiches, it will find the sandwiches in there. I can control the representation. I can visibly look and see what happened. And this is especially important when it comes to RAG, or more broadly LLMs, because I don't necessarily know what LLMs are doing. I know they're doing something and that's often very intelligent, but what is happening I would like to see, which is why I like graphs. This is what's easy about graphs. I'm not sure if you guys would agree, but if you make a graph for someone, they very quickly look at it and can say, oh, I get it, but why is it this way? And so then you create this broad discussion as to what was made and exactly why am I doing this, if it's something that you can see. Problem with graphs is that once everyone can access that, right? Everyone can look at what it is that you've created. Everyone can have an opinion of what you've created. So part of the difficulty when we make graphs for RAG is that it's there to answer a specific question. But I was, through my PhD, at a conference in Oslo at DNVGL, which was amazing, but I saw a 4-day conversation about terminology like what is a process, what is a system. While these are very necessary conversations, the difficulty is how many different people can contribute to this. If you are making a graph like a snowman, that is exactly what it should be. It should be agreed upon definitions. It should be broadly applicable, and it should be a consistency of medical knowledge in this example, right? But for RAG, when you look at knowledge graphs for RAG, it's like, well, the paradigm's a little bit different. Because RAG, in this instance, at the current iteration of RAG, is just answering a point question in time. And it's really just, RAG is what's the gap between what does the LLM know, what does the LLM think it knows, and what do I want it to say specifically, right? So graphs have become this very accessible thing to augment RAG because everyone can see them and be like, this is what the LLM should do. However, that's not necessarily the case when you go through the RAG process. LLMs happened in RAG. I'm not sure about all of you in the room, but at least for me, that was a significant moment. And I'm referring specifically to GPT-2, I guess would have been the first one when we had an academic license when that was released. GPT-2 was a fascinating moment in time where people like all of a sudden, we can't release this model and its weights because they're going to make news articles. And that's a problem. And that has now been blown past completely. Now you can argue that the majority of news articles are using this generative stuff. But LLMs significantly changed it for me for the main reason that was in GPT-2, now I can do extraction. And you're probably similar in that with GPT-2, now GPT-3, GPT-4, any sort of LLM you want to use, the extraction process of unstructured text into structured graph that I can ask questions of with the ontology or with the alignment that I want is now able to be done end to end because of LLMs, at least in our case. I'm not sure if people in the room have a similar situation, but LLMs kind of quite significantly changed it. I was pretty impressed when I first used GPT-3 to make a full OWL file. I didn't necessarily expect that would be able to do it so effectively, so efficiently. It was really close. But it was never perfectly usable, I think was the problem. But when I worked in graphs for a long time, part of the difficulty was getting started. And I do think that LLMs made it very easy to get started. What they did also do is brought many more people to the graph community, because all of a sudden this esoteric language that you previously couldn't touch, now you can create, right? And we have the developer, founder of Shackle here at this conference, and it's a phenomenal language, but the phenomenal constraint, but now people can just write a Medium post about how I made a graph, and it's in Cypher, and I made the whole thing. I've never done graphs before. I just asked an LLM to make a graph, and now I made a graph, right? And they're like, this is really cool. It's almost there. It's just missing this one piece. And I think people think with LLMs that there's a linearity to improvement. But really, when it comes to RAG and it comes to LLMs, you're at the end, really, and there isn't necessarily improvement. It's actually a risk of going backwards, which I think people don't necessarily appreciate. So what LLMs did is bring everyone into making graphs, because everyone can look at a graph and be like, that's easier to understand than my relational database. So now I know what my data's doing. Why isn't it working? Is a question that we get a lot. So we didn't have to do extraction anymore, right? And so I went from being like, now I have to tell Spacey exactly what to extract. And instead, I can just prompt an LLM. I can write in English, hey, there are people in this bit of text. Get the people out and give them a tag person. And now I have a graph, right? But this isn't really the case. I don't know if people have done this. When I first tried to do this, I was like, fantastic. This is going to work really well. I can just ask it and it's going to make me a graph. And that's not necessarily the case when it comes to this level of extraction. Have people tried this? I'm sure people in this room have done this, right? Like as soon as ChatGPT came out, it's like, make me a graph, and then you had a Cypher statement, and then you pasted it in and it didn't quite work. Okay, I'll try and change it a little bit. And then you're like, well, it's a property graph, so maybe it's .name instead of .text, then you have to change this around. And all of a sudden you realize that while it's getting really close, it's not necessarily making you the graph that you want. So LLMs can do extraction, but can they do extraction to the point of some of the graphs I've already seen presented today? No. They can bring many more people into the idea that I can extract structured representation from my text. They can't necessarily make perfect, structured, consistently opinionated, reliable extraction from my text. This is RAG. I've talked about it a lot, but this is the stuff that we work on a lot. And RAG is broadly just, there's an LLM, it's trained on a bunch of stuff. I'm sure everyone knows this, but just in case for people listening, RAG as we see it, and we as a company work with people doing RAG all the time, and we have entirely inbound from people whose RAG doesn't work. So we get to see a lot of these reasons, but RAG is the LLM that I'm using doesn't know what I want it to. So I'm going to give it the extra information. And this is where the concept of few-shotting comes up. I mean, few-shotting's been around for ages in terms of giving examples to a model. But you can think about prompting as a natural language way to few-shot if you want. And so separate or chunk my documents into sections, right? So whatever document you have, separate it, right? And the separation is largely because I have to embed them, right? And embedding models are a really important and I think broadly underexplored, under-talked about area of where RAG is, right? And so you can just, OpenAI provides embedding models. There's plenty of brilliant places that provide embedding models, but the reason you chunk it is that if you want to embed or model your data, it just has to be a bit smaller because you're limited by the provider. But so really you want to split it up. You want to set all of your documents into basically paragraphs, and you want to put those paragraphs somewhere, but you want them to be embedded through a model, right? So when I get the information back, it's the most similar to my question. So when I say query the vector store, right, that's because I'm sure you all know, and so you embed it, turn it into numbers, put it somewhere, and then the metadata is the raw text that you have, and then you bring that back. You query the vector store by just writing a question and then seeing how similar that is to one of the chunks or many of the chunks. Then you get those back, and then you basically just give those chunks to an LLM in some way. And then LLMs are really, you'd say, really good at two things, being translation and summary. It's not necessarily language translation, it can also be code translation, but any sort of translating concepts. And summary, so if you give an LLM a bunch of text, it'll summarize it really well. And it can summarize it in the context of this. So what you do is write a prompt and say, here's my question. Here's all the context related to that question, answer my question. And that's an LLM doing summary, and that's great. So this is basic RAG. Now, these terms are emergent, so I'm sure in a couple of years, basic RAG is going to not even be a thing, or RAG might not even be a thing. You can argue that information retrieval was already around and people have co-opted this as a term. But this is what people are talking about when they say RAG. And RAG's become really popular, I believe, because of its accessibility. Because everyone's like, ChatGPT is great, but it can't answer the question that I want. It can tell me how to bake a cake or I can plan a holiday with it. But if I have a question about what I'm working on, I need to give it something. And then obviously ChatGPT's interface allows you to update documents. And they have a RAG process in the background, but broadly, this is it, right? Here is where we see it failing most often. And I'll go through these in a bit of detail. So the size of the chunk and where you split can determine how good the retrieval is. So how you chunk is really important because then that determines what is embedded, right? So where you split your document, for example, if you have like a breaking page, or like if you just split by 512 characters, which is a really common way to split, right? And you just loop through and split your document in pieces. You could go across a chapter. You could go from the conclusion to the appendix. Like you could be bringing in information that's not relevant. You could go through definitions that don't matter. You could split at the wrong point. So making sure you have an intelligent level of splitting, and then the size of the chunks need to be big enough to maintain your context, but small enough to also be giving the specific context, is a really difficult problem. And this isn't like a solved problem by any means. There are plenty of methods to do this, but this becomes a level of granularity, which is like, well, what is my document? What are the documents that I have? Can I automatically just rip through these and build it? How can I make sure that when I chunk, it's the right chunk that I want to bring in? And the answer is you can't. And the benefit of LLMs is you can test, but this is an enormous problem. People don't necessarily go there. I mean, data in, data out is a way to look at this, right? So if you have, this is not to mention, I'm just talking about raw text. If you have anything multimodal, if you're trying to get into a table, if you're trying to get into like a spreadsheet, where you chunk is just, if you just remove the structure, now you don't have any text anymore. So what you give to the LLM is really important, right? And this is just the case of if I want to ask a question, like who are Jerry's friends, right? In that Seinfeld example. And I've chunked this script. Like, how does it answer that, right? The LLM might know already, so you can kind of get away with it. And a lot of RAG systems, like we've worked with some legal clients who have built this like RAG system that like we have 400,000 legal documents. And GPT-4 is amazing. It's solving 85% of these cases. We just have a few edge cases. And it's like, you don't have edge cases. GPT-4 is just really good at answering questions around this specific legal. Right? You're actually giving it the wrong chunks. It's just, you're getting away with it because this is quite an intelligent LLM. So you haven't actually improved it. You've just, you've basically just asked GPT-4 a question. It's ignored the chunks you've given it, and then it's answered. Right. So you don't have any way to linearly improve. If anything, you're going backwards. And so then how well does the embedding model align? And how easy is it to get the right chunk is, again, like I'm saying, massively underexplored. I did my PhD in graph embeddings, and the embedding a graph is a really interesting way. But when we look at embeddings now, it's really, it started with NodeDirect, WordDirect stuff, and that's a lot of what I'll look at. But the embedding models are publicly accessible. I think companies like Voyage are doing amazing work when it comes to domain-specific embeddings. But if you can split accurately, right, your document, and then you can pass it through an embedding model, then that's going to determine how good your retrieval is, because it's just mapping embedding model to embedding, right? And so, to give an example about a problem that we currently have at our company, we have an enormous legal document, and they have a definition called vehicular capacity, right? And so vehicular capacity is assumed by the model and assumed by us to be how many people can fit in a car, right? Vehicular capacity is defined in the document as how many cars fit on a road, which is like quite confusing when it comes to this process, but you don't necessarily have a way. So if the embedding model, had a bunch of examples about vehicles in cars, vehicles in roads, now you have a level of tweaking, right? So you can see how you can improve it. You can also see how if you're trying to solve a specific problem, for your company in your domain that a generalized embedding model doesn't necessarily do it. And a generalized embedding model, again, show you how to bake a cake, can get you pretty close, but the embedding model and how you split is largely going to determine what it is you get back. Further to this, we worked with a travel client, and they had custom travel itineraries, and they're all YAML files, right? So we had a custom embedding model. We chunked it properly by description because it was YAML, so it was structured. Even then, we would get questions like, and so it was custom wellness travel, and so people could just type in what they vaguely would like to do. So the question was like, people would be like, I want to go to a European beach, right? So that is a short, kind of curt statement. Matching that to a chunk, and these chunks could have a lot of context, is close enough. It's point, but it's not keyword matching. It's matching on embeddings. It's matching on semantic similarities. So European beach is good, but there's very little information. And then the other end of the spectrum would be people saying, work's been really tough lately. Like I'm thinking of getting away. I'm not exactly sure where to go. So how do you take those two separate ends of the spectrum? And that's assuming people ask the right thing and they don't type the wrong thing in there. So how do you take those varied questions, embed them with a model that handles all of them, and then retrieve the right size of it? You can see how there's tiers, and there are different ways to point improve it. And then this gets to context poisoning, which I think is particularly relevant for knowledge graphs and RAG, and it's relatively new as a term, and I haven't seen it talked about a whole lot, but if I have a top K of 10, what will happen is when you retrieve from a vector store, you can set how many chunks you want back, right? And that's a variable that you can pass through, and it matters. But let's say I have a large legal document. I use legal documents a lot, but I think it's particularly pervasive in this, but maybe anything regulatory, right? I have a large regulatory document. There is a lot of boilerplate in this document, right? We have 100 documents. A lot of the words are just repeated. I don't necessarily want to chunk everything, but if I set a top K of 10, and if I can correctly match my query, and then I can correctly embed and I've correctly chunked, based on semantic similarity at a high level. If I ask a question like, of the LPs in this fund, who has the best fees, right? How it can get back 3 of the chunks that have the information, right? Like LLMs can often get back the right information. But if I set a top K of 10, I just got back 7 chunks that now are not relevant. So I've gotten back 7 bits of information versus 3. Significantly more of the information I returned is incorrect and potentially confounding in a really important way. Because LLMs are not apologetic or they're not contemplative. They are necessarily confident. So if I context poison, that is me few-shotting my model wrong. So when it comes to RAG, I think people are like, cool, I've got a baseline LLM and I'm just going to add to it and it's going to be better. It's like you're actually at risk of making your LLM significantly worse. Like in the legal example I talked about before with the plenty of law codes, and GPT-4 could answer the question. If it can't answer the question, it's going to use the context it's given. And if you give it the wrong context, which if you look at someone's asking a vague question that you have to embed using a model you don't necessarily understand or control, and then you've just broadly split your document up into sections. It's like you can absolutely get back the wrong, getting back the right information is not even guaranteed. I think a lot of people get away with it. And then finally, the model and the LLM don't know what you mean, right? So to use that travel example before, that was a chat conversation where people could say, I want to go to a European beach. And then people would say things like, I want to go somewhere warmer, right? As an interactive process. So does warmer mean a warmer country like Thailand? Or does warmer mean, like if you say I want to go to a beach in August, does warmer mean Europe? Does warmer mean Indonesia? What does warmer mean in this context, right? And that depends on the embedding model and what you've embedded, but does it even know what you're asking for? If I ask for vehicular capacity, what is the vehicular capacity of this? Is it going to say 2? Because that's how many cars can fit on this road. And am I going to interpret that as only 2 people can fit in these cars? So the basic RAG can fail in a lot of different ways. This is a quote from Andre Karpathy, who's phenomenal in the space. Everyone's probably come across him, but this is part of a much larger tweet, which I'd recommend from December 2023. But to broadly summarize, he says, LLMs only hallucinate, right? So an LLM is a generative model trying to make things up, right? And we're happy with the hallucination until we're not. I think is a good point. When we first started this business, we heard a lot of people talking about edge cases in RAG. And an edge case implies that this thing is deterministic and it just fails at a particular area. But no, it's all of these LLMs are generative, and that is something to celebrate. But I think the important thing here is the LLM assistant has a hallucination problem, because once you try and use this generative model to solve your problem, now you're getting to the point where it's like, well, there's a difference here. This generative model that only hallucinates, and maybe we're not as smart as we think we are, but those hallucinations seem to get really close to what we think we do. But there comes a point where you can't stop all of the different hallucinations. And so if you want to talk about edge cases, difficult. So this is how to improve RAG that we work on, right? And there are so many different ways, because RAG, as we like to think about, is a process, it's a system, right? This is a modular process of retrieval, potentially passed through many agents, potentially conditional. So there are so many ways to do RAG, right? And there's so many ways to improve it. Llama Index has really great series on advanced RAG. Now, almost everyone who writes a Medium post has written how to improve RAG at some point, who's working in the space, right? So I'd hesitate to look at all of those over and over and over and over again, but I do think Llama Index, and particularly Laureate Llama Index, has some really good stuff around advanced RAG. They have infographics you can easily share. They have points of improvement. The important thing to notice about that is that so many of them are not, how do you improve RAG? It's like step one. It's like, no, there's this enormous kind of spider web of different processes depending on your problem. Because again, this is information retrieval and it's broadly applicable to everyone. Everyone's trying to solve different problems with the same technology. So if you do want to know and you're more interested, there's that. But one of the ways is graphs. And the way that we broadly solve it is graphs. And so I'll speak about graphs specifically. Also, advanced RAG and basic RAG is kind of like shallow learning and deep learning, right? There isn't necessarily a distinction between these things, and I think that the process is evolving. So I hesitate to say advanced and basic, and again, because the lines blur and it's never really sure, but I think these are the terms that are broadly used online. So if you are at this point where you're like, I would like to know about how my RAG works, I'm interested in graphs and others, there's prompt improvement and there's re-ranking and there's just this phenomenal stretch, but I would look at it. But I'll specifically talk about graphs. This is broadly our point, right? And I think if we're looking at within the context of, there are some companies here who have phenomenal, like really capable, really intelligent, really well-reasoned, really well-described knowledge graphs. That is not necessarily what people in RAG right now are doing. Again, if you read all the Medium posts, someone just kind of like tossed a document in and made a vague graph, and they're like, look at this picture, that's crazy. Because everyone can see graphs, right? And one of the people we work with, a friend of mine from my research group, was like, the problem with knowledge graphs in RAG is that everyone can look at a graph and see it and be like, wrong. You're trying to describe a representation of language that you're telling an artificially intelligent agent what to do, right? So you're really being like, how do we build the brain of this thing? And that is a very difficult question to answer, but it's very simple to critique. So this is broadly the question. And I think this, at a high level, this is a good answer. Because when we look at the issues that we had with RAG before, there's a paper that came out recently. I can't remember the exact research group. I'd recommend reading it, which is around structured grounding. And so structured grounding is, to give an example of a client we work with, it's a veterinary radiology group. And there's very interesting things around veterinary radiology in that animals don't sit still. So you can't build a good test set for vision. So there's just like this very broad, pictures. So then radiologists get these pictures of an animal and they're like, this is a 5-year-old Labrador. It's got an abdomen problem. It's just, I'm going to type in these things to ChatGPT and get it back. And it hallucinates like you wouldn't believe. Because it's searching semantic similarity, the latent space is unbounded. And the best hallucination I've seen is that there was a developer working in TensorFlow, building machine learning systems. And there is an optimizer within TensorFlow, broadly called ADAM, but ADAM stands for something. And then the Copilot GPT-4, so a very capable model, hallucinated Adam as John. So it got an error that said John is not part of the TensorFlow package. It's not an optimizer, and that's crazy. But I think that's funny on the surface and terrifying in reality, because it's like, well, now the space of what you're searching is entirely unbounded, right? I think an under talked about or less talked about method of hallucination is mean reversion, in that we work with a code gen client working in Solidity, being the language that's in Ethereum. And that's what Ethereum writes their contracts with, this language called Solidity. It's based on JavaScript, right? Heavily based on JavaScript. And there are significantly more JavaScript examples online than there are Solidity. And so a lot of the hallucinations are actually going back to JavaScript. So it's not making something up randomly, it's reverting back to the mean, which is this context. And so again, if you had a developer, a Solidity developer, they know that they're only working within Solidity, right? So when it comes to the veterinary radiology example, it hallucinates conditions for these animals. If you gave it to an intern or a research assistant, they would know that the disease that it's associated with a Labrador only applies to bulldogs, right? But you can't necessarily limit that when it comes to LLMs or RAG. Again, you just gave it text, you gave it an embedding model, you asked it a question. And if it can't answer, it tries to figure it out. And it doesn't figure it out in the right direction necessarily. It can figure it out in any direction, entirely unbounded latent space. So, and I'll tell you that the accuracy of this level of granularity of veterinary radiology using GPT-4 is about 20%. And this is not to say GPT-4 is not a good model. It is. It's fantastic, and I use it every day. But when it comes to some levels of granularity, it doesn't necessarily answer the way you want. So structured grounding is a really important part of knowledge graphs in RAG. Because now we can represent, this is a dog, it's a large dog, it's a Labrador, and it has these diseases. So you've bounded the search space. And that structured grounding is really important. If you have an existing knowledge graph, or you're willing to put in the effort to build one, or you can use some of the technologies to build a few, or however you want to do it, structured grounding of your answer is really important and really useful when it comes to RAG, because you are trying to answer a specific question over and over and over again. You're not trying to answer all of your questions almost. And I think that's a difficulty when it comes to this process. Completeness of answer is really relevant. Again, if I have the Seinfeld and I say, who are Jerry's friends? In the process I described before, this is counting, right? And so if you want to do counting, you shouldn't really use vector databases. They're very aware of this. If you want to count, like in the travel example, how many of the tours are in Mexico is not necessarily a good question for RAG, right? Because I've chunked up the tours, so maybe they're in like 3 or 4 parts. And let's say there's 100, I've got 400 chunks. Like it's not going to count them necessarily. So that's where relational databases are useful, or graph databases are useful. But if you want to do qualitative counting, if there's such a thing exists, who are Jerry's friends, right? The RAG process doesn't necessarily give you back, like you'd have to get back every chunk that mentioned friend with different people, and the LLM would have to take all that information and condense it. And I think an LLM with that instruction, with a question simple enough as who are Jerry's friends, can probably do it, assuming you get back the right chunks and you don't confound it, and you don't mention someone else. In a graph like I had before, let me jump back to it. If I go to Jerry, like, and again, because I've got the chunks here, I'm just going to remove these chunks so we can see it a little better. Again, the chunks are really important, but this is a case of, I spoke to someone once who was like, graphs should never have more than 10 nodes because I can't see them. And I think there's some validity to that sort of statement. If we go in and say Jerry, and so we have friends with, right? So I can just go, I guess we have the counts. Wrap. I'll have to wrap this in a string. Actually, I probably shouldn't mess around with this too much. Maybe this is going to break, so I go stringify it. Right, so now this is the type of, that's a pretty simple query, right? And there are problems with query generation from natural language, I'm sure you've bumped into, but now I have a complete answer. This is an awful network, and you can see there's some uppercase and lowercase and whatever. We fix that by just lowercasing all the text that we have. That's not the point. The point is that this is a complete answer now in a way that will be difficult to recreate with RAG. So relatively simple query. You can get it back as a table, whatever you want. And the benefit of what we've done here with the schemas is like we pass those schemas into, I genuinely try to use LLMs only if I have to. I think LLMs are a fantastic and very interesting prototypical tool. Our backend basically doesn't use them because it uses them for some level of querying, I think generation code. But you can see that if I ask this question to a vector system, and maybe people have different opinions, but this is something that we've seen a lot, which is like completeness of answer. Multi-hop retrieval is harder, but anyone who works in graphs would know that multi-hop retrieval is really relevant, right? Which is like, if this happens and this happens, then get this back. Or like, I think the canonical example that we had in the literature was like, where does Barack Obama's wife live? And it's like, well, I don't necessarily have that fact. I have an open world assumption though, so I don't necessarily know. So it's like, I'm going to retrieve that information. When it comes to RAG, multi-hop retrieval is really useful because LLMs should be doing translation and summary right now. You can prototype and test and explore with them doing reasoning if you would like to, or planning, right? But really, if you want to get a level of reliability, you can't. If you want to put a product out there that people can see, you cannot rely on an LLM. You're more than welcome to, but again, you get an edge case. And then that edge case you can't fix, and then all of a sudden there's no reliability in your product. I built a large RAG system, didn't have a graph in it, for a large oil and gas company as a contractor. And it was just a leave policy, right? And so you could be like, well, how many weeks do I get for paternity leave? And it hallucinated a little bit. And then everyone in the company was like, oh, this sucks. And they never used it, right? So like when it comes to that level of reliability, multi-hop retrieval is important. Most questions that are useful aren't who are Jerry's friends. It's of Jerry's friends who are balding, how many of them have a job right now? Like that is the type of structured question that you want to use, right? That has some temporal process, potentially spatiotemporal, but it has a level of conditional hop. And I don't want to get an LLM to do that. But if my graph has that information in it, my graph is specific, the relations are there, there's a level of path that I can follow. If I give the LLM that, it can answer my question, right? So multi-hop retrieval is really, really useful. Part of the difficulties people in this room may have seen is that getting that multi-hop retrieval from natural language is really difficult because the queries that you want to create, if you want to generate a query, it's difficult. Yes?
So question, when you use graph to find the chunks in PG, right? And that's what you're talking about. But my question is, right, we can use, because we extracted, we can use graph to answer the question, right? Or we can use graph to retrieve me a chunk and then I ask LLM to answer the question. Or we do both.
Yeah.
What do you think? Because, you know, I did both, I never did together. So what do you think is the right strategy? Because I'm bound to ontology, right? So if I have a question, I don't have it in graph, right? So then my only option would be retrieve me a chunk and I'll ask LLM to answer. Or I answer the graph because I extracted, I have a knowledge, I know what he's asking.
Yeah, if you are bound to a consistent upper ontology, I think that's really good, right? Especially if you've done the work to build that graph out consistently. And that's a difficult amount of work, but once done, it's useful. So I think your point is like, how do I use the information if I ask it a question? Is that right? So you can return back the triples, which is a complete answer. But that's like, I had an example where I worked with the first book of Harry Potter, and I'm not sure how familiar everyone is, but it's like, you can ask, if you ask a question in the RAG process that I described before, who sacrificed themselves for Harry, right? So if you chunk it, you have to hope that that's like you need to get completeness of answers. So it's like, I got to get back everything that refers to sacrifice. There's a bunch of references to sacrifice, but didn't necessarily get back that answer. So the answers are broadly, so then if I ask a graph and I have this aligned to upper ontology, which is person and condition and however it was, you would get back the answers Ron, Weasley, and Lily Potter. So his friend and his mum, right? You would just get those answers back as a triple, right? That's the triple that you get back. That's not particularly useful to an LLM. In some cases it is, but the difficulty there is I've given it accurate and complete high-level context. And accurate and complete high-level context doesn't necessarily let it make the decision. So you're between two things, right? So part of the reason why I showed the chunk linking before is that what we have as a product is like, well, also give it back. So if you return Lily, right, and Ron, also return back the chunks that information was extracted from. So then you get an answer like Ron Weasley sacrificed himself in the chess battle, and then many years prior, Lily Potter sacrificed herself for her son in that process. So I think you're right. If you're aligned, you kind of want to have it. If you just give it that simple context, it's not enough. If you just give it the chunk, it can be too much. I think the answer and what we're working on is to get an LLM generated summary. So every graph basically has a property. That property is a description or summary, and that summary is LLM generated. But if you generate that through a RAG process, then now you have each node with a particular level of description. It kind of fits in the middle. So that I think is probably the best. So you can be aligned to upper ontology, and you can get back the right answers. That's really just a matter of scoping in and making sure when you do multi-hop retrieval, you follow the right process, right? My experience with alignment to upper ontology, and a lot of that for context is I did a lot of work in ISO standards in resources. And that was a specific way to follow, like, failure codes and maintenance. And so that, it wasn't necessarily the terms, it was really what the terms related to that was really important with the graph. So I think if you have an upper ontology and you're aligned, and you want to ask questions of it, and you have a structured query language that you can do so, I think getting back the chunks is better than not getting back the chunks when it comes to high-level descriptions. But it does depend. I mean, this is why RAG is difficult, because also that's in combination with a prompt. You can write your own prompt, right? And then it's also in combination with maybe some other schema that you add in. And then that could be one system in part of a multi-agent system. It's difficult to answer, but I will say that if you get back the node and just the chunks associated with that node, so the process is node, then chunk, I think you have a really good chance at the answer. But I use the word chance very specifically there, because if you have an upper ontology, you can deterministically get back an answer. I'm just not sure how useful that answer would be. And then finally, inferred answers. I think there's a really big value for graphs. I see people coming to graphs now, and they can see them, so they really like them. And then they can be like, oh, I heard graphs do inferences. I heard that graphs can do consistency checking. I heard there's anomaly detection. I heard there's all these valuable things around knowledge graphs and what they are. And it's like, yeah, that's a perfectly axiomatically described, ontologically aligned graph that you've built, right? That is not, I made a network X diagram and now this thing looks cool. So inferred answers are a really useful potentially, again, because multi-hop retrieval and inferred answers, or like inferred multi-hop retrieval with something like Neo4j's optional clause, right? This is a way to do planning or to do reasoning with an LLM without having to let the LLM do it. So this is a really key part of, I think, the future of graph RAG, if we want to say graph RAG. I'm still not fully on that term, but I think this is the key part. And if you have an existing ontology, this can work really well. This is broadly the benefit of augmenting. I have to rush through a bit. This is Protege. If someone hasn't used Protege, it's awful and it's fantastic at the same time. I had to spend a lot of time with this. I tried to find the wine ontology, the pizza ontology, but broadly, if you have this, right, which is, again, it looks simple. It's a lofty goal, I think, to create a graph like that. If you have structured grounding, you have multi-hop retrieval, you can infer an answer. Again, if it's Protege, it's axiomatically constrained. You have different processes to make sure that the answer's right. Everything in there is consistent. Now you've given the LLM exactly what it needs, right? If I go back to my point here, it was somewhere here, I said just like LLMs can do what this, right? This point. What if we put our data in a graph and the LLM asked it things that we asked the LLM, right? That would be great if our graph was really good. And this is a really, I think, good goal to aim at and a difficult thing to achieve. It's better than just basic RAG. But this is kind of process that we're looking at if we look at graph RAG, right? And it doesn't apply to everything. Yeah, please.
I noticed from using the Protege example, when you're referring to the benefit of graphs with LLMs, are you using ontology and graph interchangeably?
Sure, that's a good question. I'm using Protege here as the example, and people may disagree, but as like, I guess the canonical knowledge graph, like this is the most, the best, the most complete, the most well-structured, the most aligned that you can create as an example, right? But when I talk about knowledge graph, and I think this is a really good point, I'm not trying to define knowledge graph because I don't have a definition, and I don't, you may have a personal definition. I think Neo4j's definition is good. I think Ontotec's definition is actually probably one of the best, but what is a knowledge graph and what am I talking about is a really good question. And I think the answer is because knowledge graph is out in the wild and because it's a really accessible concept and everyone can see it contribute, I think it's difficult to standardize that definition. I'm talking about here, the perfect would be something like this. The gaps here are how do I write a Sparkle query from a natural language if I want to go to a European beach to get back this perfect description? And secondly, how do I build this graph in the first place, and how much work is that? What if my data changes, and what if the RAG process doesn't work? It's an emerging process. So it's a good question. I use this more as a demonstrative example. I would say most people aren't using Protégé. I would say most people are actually using database like Neo4j or Kuzu in terms of how quickly it is to get started. Because I think the barrier to entry to something like this is huge. But this would be good, I think. Here's some downsides. So if you don't have a graph, Laurie Voss says this really well from LlamaIndex, and he's the dev advocate from LlamaIndex, and he's great. If you don't have a graph and you see people using them well, I think there is an idea that we should have one, right? But making a graph is a large undertaking. RAG isn't necessarily like revenue generating. So the ROI of making this, right, is hard to justify in a lot of ways, right, in a business context. So I think making a graph if you don't have one is a pain, especially if you're unfamiliar with the technology, especially if you don't know how to debug. Any sort of like, you could say that like when LLMs started doing, because the RAG is probably the second most used example of LLMs right now, with the first being code generation. And I use code generation a lot, but if you look at how much good software has been created versus how much software has been created, it's like there's way more issues. There's a lot more problems. So making a graph from LLMs isn't necessarily easier. More people can do it, but that doesn't necessarily mean it's better. Another question that you probably have that I have as well is like LLMs are pretty good already and should get better is I think an interesting point, right? But let's say LLMs get more domain specific or use a domain specific LLM or use some sort of fine-tuned or transfer learned LLM. It's like, what if it doesn't do what I say? What if the domain is vehicular capacity and that's how many people are in a vehicle? And what if I then have to, like the benefit of the high level ones that we have at the moment is you can kind of quite easily trick them. So LLMs are pretty good already and should get better is fine. I think it's really important to, when you think about graphs, not see them as replacing, see them as augmenting. And I think that it needs to be described in such a way and represented in such a way that LLMs, every new release, like GPT-5 is always rumored to be coming out, right? GPT 4.x becomes 5 at some point, and there's a competitive advantage, I guess. But as that is released, will this make graphs obsolete? My answer is no. But will this make how we make graphs obsolete? And will this make us question what does it mean? What does semantics mean? What is representation? Yes. So what is semantics is a really interesting question because, you know, axiomatically, if you're building in Protégé, things like a concept net, like an is or a has become really important, or a child-parent relationship become really important, right? But if an LLM has most of that context already and it's getting more of it, then how important is the semantics at that level? How important is high-level instruction? How important is upper ontologies? I think they're really important, but I do think there's a question that arises in terms of what does it mean to use them. So there, turning natural language into a query language, I won't spend much time on, but that's just a really difficult problem. I think people expect it to be solved immediately. It's difficult. Thomas Bratnick from Neo4j has a great project, which is like a community level of like, everyone please use examples and build them and tag them, and then we can build up something around text decipher. And I'm under the impression Neo4j are building a co-pilot around text decipher, and I think that's all really useful, and I use a lot of Cypher. However, this will always be a problem, right? Text to SQL isn't solved. There are more SQL examples online than anyone's ever seen. So if that's not solved yet with the current phase, it may be solved soon, but that's a limiter. Consistent representation over domains. We have a motivating question that I think about a lot, which is like, rice to a farmer is different to rice to a chef, but the node rice is the same. So how do you communicate that? And how do those people communicate? And what are two different modalities or two different worldviews, and how do people come to conclusion? So consistent representation over domains is interesting, especially as domains update and change and this field's emergent. And then specificity of representation. I'll just go back to the veterinary radiology example. If you're not at a level of granularity that can answer the question, the LLM's going to make it up. And that's where hallucinations come from, because you've basically guided it into a dark room and told it to figure its way out. And it's like getting to the level of granularity of representation is really important. This is why, again, the questions around upper ontologies are difficult, because if you start at a concept net, you get all the way down to veterinary radiology. How many steps are in the way, and how long does that take to build? So these are some of the downsides. Now, I mean, again, I use them and I think they're useful. Yes?
The third bullet point, I just want to make sure you're not saying that the only way to do graph RAG is to be able to convert to query language. If you are doing that, then that's a hard problem.
Yes, so I'll talk through this a little more. Yeah, so there's multiple ways, and Andreas from Neo4j recently gave a talk, and he's fantastic. If you get a chance to see him speak, I'd highly recommend it. But there's broadly 3 ways, right? One is someone like a Neo4j or anyone, you can vectorize a graph, right? So then I can actually do the vector search that I described before. There's the end case, which is type in, please query my graph about people and systems, and then get me back like a multi-step inferred yielded cipher query. That's the end state, right? There's a middle state, which is what we do at WhyHow a lot. And basically, this is, I think, a really common system, is vectorize it so I can then kind of land on a node and then run a preset cipher query that I pass variables into. So that's like the main way that people are going to do this stuff, right? And so if you have an understanding, I think the answer is structured query language, many different structured query languages, and just know which one you run. So I don't have to talk about what we're doing. Yeah, okay, so this is just, I want to talk about graphs, specifically what the features are that work for us. Again, in this room, we have a lot of different graphs, a lot of different people who've been working on this for a long time, a lot of different domains. So I don't want to prescribe graphs. Exactly as you said before, graphs are different, but how we use them for RAG with clients, this is what I want to go through. So, and this is the point. In its current state, the point of RAG is to run specific answers from vague questions. I think that's useful, right? And the structured grounding kind of closes that gap. I think this has to be really important. Reliability is a buzzword right now, but reliability has been a thing in graphs for ages in terms of determinism. But this is our mantra. Again, it's going to work for us. It's not going to work for necessarily everyone, but you have to represent the full scope of the question and nothing further or confounding per question, right? Because if you have a question, if you're asking a RAG system a question, right? And I build a graph, really just build a graph to a high level of granularity, whatever. I'm letting the LLM make the decision. You structure it a little bit, but it's like, you kind of want to start bottom up because the value of the system, if you can answer all of your questions almost, that isn't useful. So you kind of have to start by answering at least some of your questions definitely, and then expanding from there. So in the veterinary radiology example, this is a veterinary radiologist who writes reports. They make money per report. 40% of their reports are about abdomens. So it's like, I don't need to go through the process of representing specific brain injuries if I don't want to. Like at the moment, what I really need is like this kind of like power law representation of what I have, but you need to be able to answer at least one question, then expand out from there. So granularity is covered, scope of the question is covered, and then the representation is aligned to how the domain experts interact with the domain. I showed you that schema before. Again, you can few shot it wrong if you want to, if it represents your domain. I think the interesting thing at the moment is personalization of workflows, which is what is vehicular capacity, right? What does it mean to me, to vehicular capacity? Because that's really important to my system. If it doesn't know, then it's not going to know, right? For the travel example, wellness travel has different peak months to travel. So if I say, what are the peak months to GPT-4, it's not necessarily going to get that answer, right? And that's not to say if you have specific business processes that are different and a competitive advantage, that's the same level. You need to align it to what you want. So this is like a broad point, which right now, I hope this changes, but this is what we think about the most, right? Don't let the LLM think at all. Give it a task and give it everything it needs to solve that task, right? I like the saying that LLMs are not very intelligent. They're a 5-year-old with 1,000 years to solve the problem, right? Or like models generally. So give it, and they're getting smarter and smarter and smarter, right? But like, again, a newborn baby will cry if it doesn't see its mother, right? So it's like we have these processes really quickly. So you want to make sure that you give it all the data, right? But if you give it too much data, now it's thinking again. You're like, well, that's not great, right? And if you don't give it specific enough data, it's thinking again. It's like, don't do that. Give it the specific data just that it wants and no more. And so the difficult part of this is how do you do it really broadly? And so this goes back to my point of like, why do graphs so big when you make it? And this is for RAG, right? SNOMED needs to be as big as it is, and that's exactly as it should be, and that's perfect, right? The graphs I worked at in large resource companies need to be as big as they are because they represent so much. And Microsoft's Graph RAG, I think, shows communities really well, and it aligns all of your data. And this is part of the problem, right? And this is RAG specific. I think people in the room may agree or disagree with this, but in my experience, there is a large upfront cost to making a really big graph, and the ROI is uncertain. The ROI may be defined in some places, but I've been part of many projects which spend a lot of time, multidisciplinary. Someone's on leave, so we can't quite get them in, but once we get them in, that's okay. And then we can bring them in and someone disagrees in the system in terms of that's changes in our SOPs in German and we can't. So that you got to build this large system out, right? But the ROI for querying a graph in RAG is unclear. Because RAG itself, to be honest, at the moment doesn't necessarily have commercial viability. There are very few systems in RAG that are actually in practice, right? Some people are testing chatbots, but they're not necessarily making money from them. And then if you do have a graph, then it's like, well, the previous checklist being like this. I think, and I've built a lot of large scale graphs that are in production at some level, specifically around maintenance and FMEAs and stuff, or FMEAs. And to represent the full scope of the question is difficult when it comes to kind of building these large graphs. Like, is the graph that you have that you spent time on, it is useful for what it is. Is it the right graph for RAG? I think is a really interesting question. I don't think it's a one-to-one swap. I don't think you can just move your existing graph that you've spent time representing into RAG necessarily and make it work for those points that I said. So our solution, or at least the way that we're working, at least the way that we dog food and we build for clients, and again, we have tooling, but we build these systems for people, is make a small one, like make Labrador abdomens, right? Solve the problem with that. And then make it as quickly as you can, like you saw before, right? I just made a graph about as quickly as I can, right? And it's probably wrong, right? If you're a Seinfeld expert, you look at it, you're like, that's wrong. It's like, cool, change the schema, build it again, right? And then it's in a namespace, right? So if you want to do the next Seinfeld episode, build another one, or put them in the same namespace, or build this graph and then talk to them. So you need to do it again until you solve your problem, and you're going to have many problems when it comes to RAG. But this is why, and again, I know that large graphs have value, and I know that we've spent time on it, but I want it to be evocative to the point of like, if it's representation, right? And LLMs now know a lot of stuff, then why do we need to give graphs everything if LLMs know a lot? You're really just trying to give it where the LLM isn't there yet, right? Again, you don't want to let the LLM think, but it does know stuff. It can just consistently give you back answers about things. So when it starts to kind of, again, lead it into a dark room and let it get itself out is like a really bad way to do this process. So this is just answering the same one before, which is questions and then answers, and then I just kind of want to say that this is how we solved it for ourselves. We started to build this example, and then we realized that RAG clients are like, well, the clients that we're working with, it was legal and travel and financial and regulatory, and they don't actually want a large graph to solve their RAG problem. They want their question answered, and they don't really care what it's in at all, right? So again, this is all in the scope of RAG. I know this is a conference, and I'm looking forward to going to some of the talks around large graphs and how they work, and they're particularly interested in the ESG talk, but I think that how to make it work for a RAG query is it needs to be really granular, really specific, not confounding, completely represent the scope and no more. And our way to do that, which is a little bit of a cop-out, is just make it a lot smaller and don't represent the whole domain, or just scope it in to the point that you answered that question. So I'm just going to go through some problems and some like broadly where we arrive at this piece, right? So this is vaguely right at a high level. If the LLM made something up, give it information so it makes less stuff up. I poisoned the context because I gave it too much. So cool, now do a knowledge graph. So this is where knowledge graphs start to come in, which is like structured grounding, right? My domain isn't fully represented. It's like, cool, build a knowledge graph of the domain, right? So now I made a graph, but my domain isn't represented. It's like, cool, add all the stuff in there, right? But then you start to get to knowledge graph specific problems, which is my graph isn't representative of how we work. And it's like, okay, what we want to do is that like, when I think about resources, we have people in procurement, we have people in supply chain, we have people in operations, and then we have specific geologists and chemists, and we have a bunch of different people who contribute to this problem. I do not want to give, I shouldn't have control of the schema for a chemist, but as a data scientist, I sometimes have to. If you give a natural language schema as a JSON document, then the chemist can control what the chemist needs to control, and they can look at what they need to control. Then they can consistently represent, now the domain is represented, the granularity and the specificity and the opinion of the domain expert who worked on that. This is the conclusion we broadly came to, which is like, I can't represent everything in veterinary radiology, but it turns out I don't have to, because the question isn't, how do I answer every single question in veterinary radiology completely? The question is, how do I solve these reports that I need? So reduce the scope is broadly what we looked at. And I know that contradicts a lot of stuff around completely represent the domain, right? But I'm not looking to completely represent a domain. I'm looking to solve a RAG question. At least that's what I'm paid to do. So this is the process that I develop people in this room may be similar. It does require, if you're perfectly aligned to upper ontology or if you're in an ISO standard, it's less applicable. But this is how I build graphs with LLMs, which is I build it, I look at it, I go, that sucks. And then I look back and I change it and I build it and I go, that sucks too. Turns out I wrote the schema wrong, so I'm going to change it and then I'm going to update and look and update and look. But if you can build a graph like I showed you in like a minute, then you can get in like, 30 iterations in an hour and all of a sudden you're like, well, now this is pretty good, or I can ping the right person with Slack, because it turns out me saying Jerry friends with, it's like friends with isn't specific enough. Or if I'm in procurement and I'm not really sure what this word means, you can ping the right people or give it to them, but making it representative, I think, is really important when it comes to the RAG process. This is a question we get a lot. My answer of, do you have any evaluations, is no. And I don't want to talk about them anymore, but I keep getting asked about it. So what I will say is that benchmarking this stuff is, I think, a waste of most people's time. You can benchmark it for your specific use case if you have specific people using your specific stuff, right? But if I was to benchmark a graph RAG solution, how is that indicative of your domain and your granularity and your specificity in the way that you query and the way that you work, right? So how do I evaluate this stuff? It's like, well, I have a question answer set by the people who know what means, what it means. And then I'm just gonna, we're not affiliated, but it's a mild plug, I guess, is that like, if you use something like Langsmith from LangChain in the LLMs, it's like, well, then you track every question and answer, and then you can look at it and say that's wrong, and then you can look at the evaluations, you can look at what the LLM generated. Tracking what you did builds you this QA set really quickly. So like one of the best ways to evaluate this stuff is have a question answer set. And one of the best ways to build a question answer is use the system a lot. If you're anything like me, you're using the system a lot already. So it's like store them in a structured way and test them. But I think evaluation is a really good question. How do you evaluate this? And the unfortunate answer is a domain expert needs to look at the questions and answers and see if they're right. If there's a better way, I'd love to know about it. But I see a lot of people writing blog posts and stuff around evaluation. And I just look at it, it's like, this just seems different, or it doesn't solve my problem, or I don't know what to do with this. So it's like a QA set's really how to do it. So what if the graph's too small? I think is interesting, right? Because I've just suggested the idea is like scope in the domain. And it's like, why did I just build a graph to solve one question that I don't actually have a lot? There's power law arguments, but I said before 40%, it's like 60% of the rest of that is done, right? So do I have to tear down asymptotically to find what I need to find? This is an interesting question that I want to talk about. Now, I'm not sure how many ontologists are in the room, but who's familiar with the open world assumption, closed world assumption? Awesome. This is exactly the room I want to be in. Right. So LLMs and knowledge graphs have an open world assumption, right? I don't know that all these facts are here, so I'm going to make stuff up. But I told you making stuff up is not really what we want to talk about, right? So I don't really want to make things up, right? I don't want to let the LLM make things up. I'd actually really like it if I closed the world for the assumptions that it was making, right? And then that's limiting in a frustrating way. Another insight is that most workflows are decomposed into tasks, right? So we think about travel agency a lot. And by the way, if anyone's looking for an LLM graph RAG product, I think it will be a travel agent, because I think that's the easiest to extract and the most aligned to upper ontology really quickly, which is just like locations and prices and people. It's like, it's the least likely to hallucinate and extract. So if anyone wants to like build a cool, I don't have time, but if travel agency would be great, but it's really like, I haven't booked a flight with an LLM yet, right? Because I'm not really trusting, I'm not really ready to, I don't think it's reliable. Like if each of these are agents, right? Then if this is 95% accurate, right? If there's 5 agents and they're 95% accurate each, and by the way, 95% accurate in a RAG system is a high bar, right? But if I have 5 agents together, chained, 95% gets out to 77%, right? So 70% of the time I book my flight and it doesn't work is not acceptable. So agents can do tasks, right? And so our broad point is that give an LLM the least responsibility possible and then have a lot of them. And each LLM can be assigned to an agent, and each agent can be assigned to a task, and each task can be assigned to a domain, and each domain can be assigned to a graph, and each graph can be assigned to a schema. So when I talk about small graphs, the point is make one schema per graph, have one to many documents per graph, have one task per agent, have one graph per agent. It's like, well, now the point of what I talked about, which is like get really granular in what you built. When I talk about what's rice to a chef, what's rice to a farmer, if I have a farmer agent, I have a chef agent. Well, now I have two different domains, and then I can be specific in the schema about what is rise to each one, and then they can communicate just through prompting. I can IO test the whole thing, and now I can incrementally improve the schema to get each one from 95 to 100. So now I have full control with specific, like one of the best examples I can think, we're a long way away from someone doing their full supply chain with this. But if I think of like a global supply chain, and I think of how many different tasks there are, and I think that I can split them down into agents, and I can incrementally give each individual the schema and the documents that are required, and then I have a process to update that schema and update that documents relatively easily, then I see not one big graph managing a global supply chain process, because that seems unwieldy, and if someone's built them, that's fantastic. But I see many, many different agents, each with their own domain, interacting with a supply chain like that. So this is why we like small graphs, just easier to make, right? So whichever way you want to define schema, ontology, hierarchy, taxonomy is like people talk about all different ones, but you can define the scope of the agent, right? So if I go back to the open world assumption, right? Open world assumption is necessary for what we currently have. If I close the world, I have a closed world assumption, and I have everything agentic, right? Then what I have done is been like, well, now the agent isn't making things up. So I close the world, and that's limiting, but it's okay because the agent only has one task to do. And I actually only want it to do one thing over and over again. So why we like small graphs is we're solving workflow problems, and we like using graphs to do structured grounding. But if you break those workflow problems down into their components with the individuals that matter, then we can build this faster. LLMs and knowledge graphs use an open world assumption, right? If you have many agents, you can use a closed world assumption. And I'm very happy to discuss this. I know it's a broad philosophical topic and I'm very interested in it, but I'm taking some liberties here. But I think broadly, it's like LLMs need an open world, knowledge graphs need an open world. No knowledge graph is complete, but you can work on knowledge graph completeness. But if you have an agent, you close the world, I think that you can make it consistent, and then you can improve it iteratively, and you can get to the point where it's like, now how am I evaluating this? It's like, well, it's just the domain, just the schema, it's just the process. Yeah.
Is the assumption here that most of the queries are localized to a given domain? Because if you had queries that by definition traverse multiple domains agents, then you're back to the same problem.
Yeah, so I guess that the idea is like, I think that RAG, which is like a natural language query and then a response, right? Maybe a multi-agent response, isn't really how the future of work's gonna be, right? I actually don't really want to trust that. So I think that how you orchestrate a multi-agent system is really important, right? But I think your question is like, which agent does it apply to? And my answer is like, if you know the workflow, that should never be the question that you ask, right? Because, and I think it's a very good question to be, but it's like, if we think about travel agency, it's like, I would like to do my flight here, right? I've worked on this before. It's like, take that natural language query, extract the relevant information, which can be done with space. It can be done almost deterministically. Then just pass those off into what are effectively SOPs or decision trees of like an agent flow, right? And then I actually don't have to worry about natural language decipher because I can just write pre-built cipher queries, right? And then IO for agents is now like, well, everything's JSON or everything's Pydantic, or I can pass the whole thing back and forward. And so I really just kick off the process like we described before. If someone asks a graph query and you've vectorized your graph, I can just map it to the right node or nodes, and that's actually what we do. And then I run preset queries. So this is just doing that, but over and over and over again. And so what I do is just like each agent or each task or each conditional description in the tree, in the flow, is in that process.
Doesn't that assume that there's one entry point to your workflow?
Not necessarily. So yeah, at the moment, yes. But like if you look at RAG, there's one entry point as well. But I think that the way that we've done it is like, well, let's say you have different personas in like a marketing situation, right? And it's like, well, you can just multi-class classify and then just kick that process off. I'm not going to say this is a deterministic process, but yeah, absolutely. But how you then classify, I think the important thing here is that a lot of these are software engineering problems or machine learning problems that have been solved in the past. And so a lot of the issue is like, how do I reduce the stochasticity of the LLM? And so when it comes to like, if I just ask a single question, can I just route it to where I want to go? And I think that's largely a solved problem. The difficulty is describing the processes. I'm not saying it's easy. I'm just saying that this is a way to reliably multi-agent solve a workflow. Yeah.
You mentioned previously aligning with an operative ontology.
Yeah.
Isn't that supposed to harmonize between the different domains and the different?
Yeah. So my push, and again, I spent a lot of time with upper ontologies. I think that they definitely have their place. But like, if you've closed the world and the agent's there, then what do you need an upper ontology for? In that agent, right? And so the upper ontology is necessary. But you could also argue that like a concept net is probably in the LLM already. So it's like, what am I really aligning to? And it's like, well, I'm actually aligned to the LLM now. So it's like, if I can put a level of trust in, like, does an LLM understand a parent-child relationship? It's like, I don't think it messes that up very often. it messes up a granularity. So then that's part of the process. So you can add upper ontologies. You can create the schemas as much as you want, but that's at least something that we've noticed. And we're working more and more on it. But I think the key thing here is like we're not representing a domain. We're solving a RAG problem, and so we just reduce the domain so we don't have as many problems. Yeah, so this is what we do. Again, I've talked about it. I don't want to plug too much, and I do want to be clear that like this is intentionally provocative. I know that like there are large graphs, there's small graphs. People don't necessarily want to make a small graph. It doesn't have value. But I wanted to give an example of like why that's the case. This is an example again of the graph that we had. I want to go back to it. You could argue this is small, this is big. It really depends on what you're looking at. But this is an entire domain from a script, right? This has the chunks. This has the context. This has everything you need in it. So in theory, you could have an agent whose job is to like, you have one agent whose job is to make Seinfeld scripts, right? Or make a new Seinfeld script, right? And this is the graph that it refers to, but that's not necessarily good enough. So then you have an agent that's job is to interpret this big salad graph, right? And then that agent's job is just to look at this. And so I can have another agent, which is another script, right? There's no reason why I can't have those. They're two different schemas. So a really motivating example for this business is very early on. It was a random Medium post by a guy. He didn't talk a whole lot, but he got early access to GPT-3 as an API. And so he was building these systems, right, as APIs. And he wrote this thing called Writing GPT. So a super well-known blog post, but it's one of the most motivating that I've seen, which is like, and this is a more common workflow now, but he said, okay, I'm not a writer. I don't write blogs necessarily, but I know vaguely how to. I'm going to build a writing agent, right? And then in theory, you just type what you want and it gives you back an answer, right? It builds you content. He said, but that's not really good enough. So what I'm going to do is I'm going to build an SEO agent, and I'm going to build an SEO agent. I'm going to build an editor, like an editing agent. I'm going to build a colloquialism agent to make it more accessible. And then I'm going to build an agent that's job is to tell me where to put photos. He was a photographer, right? So this guy was like, well, then if I have this process, no human in the loop, just agent workflows. What it did is he was just like, you can make money by just like saying, what are the 10 best washing machines of 2024, right? Just put that blog post up. So he's just like, just typed it into the prompt, right? And so when we talk about that prompt and we talk about routing to different workflows, it's like, he just typed in, write me a thing about the best thing, right? And so it wrote it and it was bad. So the editor said no, and then it fed back, right? And you do have to have some level of utility functional condition on that, but it's simple enough. You can just say run it twice and it gets pretty good. And then it runs twice with the editor, runs twice with the SEO, makes it colloquial, shows him where to put the photos. Then he went and took the photos that it describes. Now he has original content and then was able to get to the top of SEO rankings pretty quickly, right? This was at GPT-3 level. Right? That's an agentic workflow. It is relatively simple. It has consistency. Again, he had a low bar. It's a blog post. It doesn't have to be super reliable, but I think the next steps are that motivating process, which is what he described as how to write a blog, right? Which almost any of us can do, right? And I can't necessarily edit, and I don't know much about SEO, but I can tell an LLM, make this SEO compliant. I'm going to put it on Google. I live in the Western world, right? Like you can instruct pretty easily when it comes to this stuff. And then especially if you're in a business that has domain experts, they can instruct even better and they can write even better schemas and they can have even better graphs. But if you think about those agents, it's like, what does the SEO agent refer to? In this example, what I'm suggesting is it refers to maybe someone's written a document, maybe someone's written a particular SOP of how to do SEO. Maybe there's some reference document, maybe there's a Wikipedia article. Well, there's in a graph and then it refers to that, right? So when it answers its question, it pulls in the structure grounding of the context. And so that's why we use small graphs to solve workflow problems, is because instead of having one graph that is very broadly applicable and I have to refer to, I can have that. And you can see at that point, it doesn't necessarily need upper ontology alignment, right? There are examples where you would, like when I think about what are the really high value, reliable questions, I think, and again, I was exposed to plant control and suspensions and failures in large operating machinery. And so those are more difficult to trust. But again, if I have an ISO standard, right, I can just use that ISO standard, and now it's following that specific process. That's the end. I think I've done pretty well on time. So this is running a closed beta at the moment. Yeah, please check us out. This is the type of work we're doing. We do a bunch of other stuff around RAG as well, but I just wanted to put this here because I think it's a good group of people around. I can talk philosophically around what does it mean to be a big graph and what does it mean to need an upper ontology and what does it mean to be semantic, which I think is interesting. But please check us out. Thank you very much. I'll stick around for some questions. Please.
What do you use to embed graphs?
Right, so there isn't any like publicly available graph embedding right now. There are some levels of graph embeddings. The Snap group out of Stanford probably does the best. And I also saw, there's a YC startup that's trying to do some graph embeddings, but I'd say we have our own because none exist and they're not particularly good. But the thing that we can get away with as well with a smaller graph is like when it comes to like things like entity resolution, it's like if you have a smaller graph, it's actually a lot easier because then you can resolve rice and what it is. Like in the example I showed, like how many Jerrys are there in the world? A lot. How many Jerrys are there in that script? 1. So like any of those is just going to be aligned. So we use embeddings for that process, but I don't know of any that are publicly available yet. I know of research projects that I can refer to. Yeah.
If you already had a big graph,
yeah,
then is the suggestion here that you should think about creating these, if I call it micrographs per domain?
So I think that's a decision, and it depends on if you've already represented your domain. My question to you is it granular enough? And I think when it comes to RAG, the answer is probably not everywhere you need it. So then the question becomes, how do I make it more granular? And there's 2 broad answers. One is make a more granular specific graph that only answers that question. And the other is make your existing graph more granular. And that's going to depend on what's your conditions, what's your alignment, how do you do that process. But I think that is the problem in that the large graphs I've used are like, again, when it comes to RAG and really specific questions, and again, this is just RAG, there's other use cases, but when it comes to really specific questions in RAG, graphs that I have almost solve all of my problems and never solve the one that I want at that point in time. So getting it more granular is like, that's a decision that you have to make. But I think that's a design choice. I think if you're starting from scratch, I think this process makes a lot more sense. If you have an existing graph, then it's how do you get granularity, and that's a decision. Yeah.
How do you define granularity in the context of the schema? Like more specific words, more general categories, like how do those tie together?
Yeah, so this again comes down to evaluation. It's really difficult to be like, what is granularity, right? What is deep learning? Where do we get to? And it's like, well, you just have the question answer set and that's kind of it. But the schemas that I showed are very general, right? Character of. It's like if I wanted to do comedian, I could, right? And this is an instructive process that extracts. So it's a really good question and it's difficult to define granularity, but as long as you're starting with a question answer set, it's like, did it answer my question? And if not, make it more granular. Which is like an iterative process, right? I wish I had a better solution.
No, this is just their website.
Pattern example that you showed at the beginning and say, full, what would you say is the sweet spot of expressivity for?
Oh, that's a great question. Yeah, I really like that. So I've done a lot of work in OWL and anything like URI really specifically aligned. And we look at schema.org a lot in terms of alignment. The sweet spot, I think, is, so, and again, the example I showed is like a similar example, right? So there's somewhere in the middle. I think the sweet spot is what we're building at the moment, which is like, I have a 1 tier, like just parent-child relations in a schema, and I have cardinality on each relation, right? And then I can build properties out if I want to, but I don't necessarily need to align to like a schema or a .org in a lot of cases. But I think the sweet spot is, to be honest, the sweet spot would be OWL if I had a code gen that could automatically build it. I think people just want to type words. I don't think they want to necessarily type the rest of it. So I think if it filled it in, that would be really useful. But right now, I think the sweet spot is parent-child taxonomy and then cardinality. Yeah. Yeah.
Maybe a little beginner question on your second last slide. I noticed like for every board, you've got, it's repeated but at different colors. You just want to know
Yeah. So this is an example of like the schema is like super basic. So it's like we completely pass all of the text for this example. And it's like, because the schema is object, clothing, food, character, like sometimes it's going to mess that up. I mean, the benefit of graphs is that it's all fully CRUD, so it's like just delete it. But that's something that I really like about the representation, but it's like, it was from a previous thing. But yeah, it's just that it's automatically finding it to some level of generation. It's like you just kind of change it. Yeah.
So you use proprietary embedding algorithm, but then when the query gives you like a subset of your vectors, in what format do you decode them for the LLM?
Oh, cool. Yeah, so we don't necessarily use proprietary. I just say that, like, again, we work with clients. I experiment a lot with local and open source models, and I think they're fantastic. They're difficult to build into a product right now. So again, you got to host your own stuff, and it's difficult. And I think a lot of people are comfortable especially with Azure OpenAI, people are comfortable bringing that sort of stuff. We store the vectors, right? And then the simplest way to retrieve that, I have an open source package out somewhere which is around rule-based retrieval. It doesn't use graphs, it's just using rules. And it's like, you really just like every vector you can just like add metadata to. And that metadata is really limited by character length. And that's a lot of what determines like how big your chunks are. So you just store a vector and then you have a bunch of metadata in it. One of those metadata is the text. So when I retrieve a vector as an object, I just refer to the specific key in that object.
Where does the text come from? It's not from graph.
No, so this is building a graph. Do you mean if you...
If I'm using a graph to augment the LLM.
Yeah. Right, okay, so then this would be a process of like, I have like high level concepts and I want to give more information like as text description. Because what I was describing is like graph generation. If you have an existing graph, I think it goes back to what I was talking about before, which is like attaching a description or a summary. Because like you can't like pull the works out of thin air. I think you use graph querying to be like, I'm going to add, if you use a property graph, I'm going to add a property like summary, and I'm going to attach that summary. And that summary is going to be what's added in as context or description. If you have a knowledge graph, you can have another node that has the description if you want. But it's a case of adding free text as some either like an extra node or extra relation or a property on what you're doing. But that is a case of post-processing. Like as in like if you have a graph that's like high level and just description, really useful for instruction. But
Was about using structures on the graph.
Yeah.
Augment the LLM to answer right questions, to answer specific questions.
Yeah.
Right, so you are giving the LLM some additional information from the graph.
Yeah.
For that, you need to first embed your piece of the graph.
Oh, are you saying how do I give the LLM the text from the graph?
Yeah.
Oh, sorry. Yeah, so query, get back the triples. Those triples are then passed in as like a variable, and they can be passed in the simplest way would be write a prompt. That prompt is a string, that prompt accepts variables, and there's many different ways. LangChain is a great way to start and try out, and we use LangChain a lot. We really like LangChain, is to pass in like the triples that you get in the prompt. So the LLM, you basically give it instruction that says, hey, here's my question, blank. Here is the context to answer that question, blank, and those are variables. And so at runtime, you query, pass that in, then the LLM does it for you.
Right, so you get triples back.
Yeah.
And you convert them into 3-word sentences.
So as in like they have to be text.
Well, do they have to be text? I guess that's the question.
Well, not necessarily. I'd say what we literally do at the moment is it's a pydantic model. So I guess it's an object. So they don't necessarily have to be, but the LLM expects some level of text understanding. Yeah.
So how triples become text for the LLM.
Right. I can tell you how we do it, which is just loop, take every triple, and because sometimes triples can be too big for the context, we just string match it. And so we just say like, if Jerry knows George, Jerry knows Kramer, that would be an example of a triple, right? That's currently stored as we have a list of tuples. Those tuples have 3 variables. Each of those variables are a string. And so then we can just pass those and say Jerry knows George, comma, Kramer, comma, Elaine. And then we pass that as text into the LLM. Yeah.
So essentially triples become 3-word sentences, and those 3-word sentences somehow.
Yes, I think it's,
Narrative.
yeah, it's a good point. I think that the state of the art is not yet at the point where it can handle like a custom object. Like we work with pandas a lot. How do I give it a pandas datetime object? I can't. I have to give it a string that is date. So yeah, it is very text-based. I think there's some really interesting stuff around multimodal, but for now, when it comes to embedding models and this stuff, it's all text-based. Yeah, but you have a lot of control over where that text is input with prompts.
So how big of an input does, let's call that like the prompt generation, where you're taking the graph and converting it to natural language? Like does it make a big difference if you do like 2 hops or like do hops and then include properties also?
Good point. So what we spoke about before is like, I have preset queries, right? And the easiest preset query is like just land on the node that best matches and then just run a neighborhood query, right? And just a 1, or if you do 2 hop, you can if you want to. It depends, and I think this is useful as like this graph, right? And it also depends on your LLM model and the size of the context. But the goal here is not to have like if bigger context windows come out, that doesn't really change my problem. My problem is reduction and trying to give really specific context only. So it does depend on what's the type of query you want to write. For us, that's a 1-hop neighborhood with all properties.
So for the properties, that won't fit the sentence, I guess, right? So you'd have to say like, like, Jerry knows somebody, and then you say Jerry is a person and his birthday is this.
Yeah, so we just have like specific string formatting. So specifically what we return as objects is a triple with the chunk and the chunk context.
Oh, the chunk, okay.
Yep, so we can give the chunk context back, but it's like we have a conditional objects that's returned based on any sort of flags you want to pass in. And that flags is like, do you want metadata or not? So we just call it metadata. So the easiest way to do this, because metadata is used in vector databases a lot, is just like the properties are really just like a dictionary you can loop through. And so you just make a metadata dictionary and then you just customize it based on that.
Okay, and so you talked about tuning like chunk size.
Yep.
What about, I feel like you could also really tune, you know, what metadata you return, and does that make much of a difference in your experience?
Absolutely, yeah. Now, I think you bring up a good point, which is like property graphs are great, right? But if I do a natural language to Cypher or GQL, I should say, the generation, like it'll break if it said .text instead of .name, right? Which is about as simple as you can get when it comes to properties. So the metadata that you return in the same way that the RAG you return, because I think that was just a kind of a motivating example of why RAG context poison. Yes, the metadata is really important. We just return all of it. The metadata that you input is really important. And so with our schemas, it's like you can add some level of metadata and can find that as well. But yes, the easiest way to change your model is to few shot it with examples, not 1 or 0, it's to few shot it with examples. And so you are playing with fire in the best way. You can make something amazing or something terrible with that few shotting. And so the most control you have over the response to your LLM is how you few shot. And so if each example has really specific properties that you've defined in your schema, then now you few shot it the best or the worst as you want. So yes, I would say the biggest control you have, the biggest control is the relations by far. And that's an emergent property out of LLMs, and that may change with GPT-5, but I doubt it. The biggest is like what is related to what. But then the second would be what is the metadata associated with each of what is related to what, and that is the properties, and so the properties are really important. Goodness. And that's a time, yeah.